Hello, this is Chris Hartman in the Mathcad education program at PTC. And today I want to talk to you about how your students can make better use of multiple representations in their math work if they use Mathcad. In mathematics education, it is common to use symbolic, numerical, graphical, and verbal explanations when solving problems or reporting the results of investigations. Today we're going to think about using these different representations involving a problem with inverse functions. If we want to find the inverse of a function f of x, like 6x divided by 4x plus 2, the first thing that we would do is set the function, or set the expression in x equal to y. Y equals 6x divided by 4x plus 2. Notice here that I've used the Boolean equal sign in Mathcad, which allows us to be the statement y is the same as 6x divided by 4x plus 2, and it won't be evaluated. Then, in the next step, I'm going to multiply both sides by 4x plus 2. So I get an equation, 4xy, 4 times x times y, plus 2y is the same as 6x. Right. Now I'm trying to solve for x here, and so what I'm going to do then is I'm going to subtract 4xy from each side. So I end up with a statement 2 times y is the same as 6 times x minus 4 times x times y. And now I want to solve for x, so I'm going to factor out x on the right hand side. So I'm left with 2y is the same as x times 6 minus 4y. And then in the last step, when I'm solving for x, I end up with x is the same as 2 times y, and I'm going to divide that whole expression by 6 minus 4y. Right. Now that I've solved this for x, I'm going to replace y with x and x with y to write the inverse function. So I'm going to write that as y is the same as 2x, that whole expression, divided by 6 minus 4x. This is the method that we would teach students for taking a function and writing its inverse. And maybe we'll call the inverse in this case g of x, and I'm going to sign that as a function 2x, the whole expression 2x divided by 6 minus 4x. Now, what do we know about functions? Well, we have our original function. Let me just pull that down. 6x divided by 4x plus 2. Let's call that f again. F of x is assigned 6x, that whole expression, divided by 4x plus 2. And here is what we're going to call the inverse. Now, one thing that we know about inverse functions is that if we graph them, one should be a reflection of the other in the line y equals x. So from the graph menu, I'm going to make an xy plot, and we'll see what that looks like. Let me just scroll here a little bit. I'm going to put x on the x-axis, and on the y-axis I'm going to put both f of x and g of x. Oops. Made a typo, which in Mathcad doesn't even require erasing. And we can see here that it looks like that might be possible. Let's reformat things a little bit. I'll double click on the graph, and I'm going to change it to being crossed. And when I go to the traces, I'm going to change the formatting a little bit. I'm not going to hide the legend. I'm going to keep it. My first trace I'm going to call f of x, and my second trace I'm going to call g of x, and I'm going to add some weight to my lines, which will make them appear a little bit thicker. like so. And since they're different colors, I'll just go like that. And now I have graphs of f of x and g of x. And it looks as if we have a situation here where they're reflected over the line y equals x. We can actually test that out in a couple of different ways. If I go here and I hit a question mark, I hit a comma, now I can actually type g of f of x. And when I do that, it pops up a little bit, so let me scroll it down. I actually get the line y equals x. So there's visual verification that I'm getting the inverse function here. So I've done my algebra correctly because this line is reflected over the other, and you can see how that's working out. So there's a nice use of graphs in this case to assess whether or not we're getting the inverse function. Another thing that we can do is we can show this numerically. We can use an index variable. So I might say x is going to go from -3, semicolon 3, which gives me a list. And now x is a set of values. And as I scroll down, there's my list x. And next to that, I can put f of x. These are the values that result. And next to that, I can see what happens when I evaluate g of f of x. So what do I notice? When I evaluate g of f of x, I'm getting x, f of x is 1.8. But when I take that result and put it into g, I get the original results back. So numerically, I'm seeing that my function g inverts the operations of function f. So finally, say in both my graphical and my numerical results, g of x was shown to be the inverse of f of x. In the graph, g of x was the reflection of f of x over the identity line. In the numerical results, the value of g of f equal to the value of x. I hope that this helped to illustrate some of the ways in which Mathcad can make your students' work in mathematics more dynamic and interactive so that they can use multiple representations to improve their understanding of algebra and pre-calculus. Have a great day.